Hi, I'm Meta Spencer, and today we're going to, I guess, Maryland and also to Turin, Italy. And we're actually going to go to the Arctic, of course, because my two guests are specialists on Arctic methane issues. And we have things to worry about having to do with the methane emissions in the Arctic. So I'm glad to have a conversation today with my British and Italian friend, Peter Wadhams, who is in Turin, Italy, and in Washington, D.C., or nearby, I guess in Maryland, is Dr. Leonid Yurganov. And these two guys already know each other. Yes, and now, Peter, if you will explain a little bit to us about Leonid's interests and introduce him to me, really, we can get going.
Okay. Well, Leonid and I worked together in the Antarctic in the winter, and in 1989. This was originally when a German ship that I was on and the Russian ship that Leonid was on were working together, and subsequently we've carried on our contacts as Leonid has moved to America, and he's really the leading figure in being able to map methane concentration in the atmosphere using satellites, and that's really a key way of working out how much methane there is in the atmosphere, where it's coming out, where it's situated, all of these things which are actually very important, but people didn't realize they were important until suddenly the fact that methane is now taking over almost from carbon dioxide as a greenhouse gas means suddenly everybody's worried about methane and wants to know about it and where it's coming from and what it's doing. So those are questions that Leonid can answer.
Leonid, please tell me how you do this, because I thought methane was a colorless gas that certainly wouldn't be visible to the human eye, and I would think even less visible to a satellite. So how in the world do you do this?
I am my background is atmospheric spectroscopy. I was born in Russia, and when I was 50 years old, 50 years old, I left Russia, and the rest of my career was abroad. And in Russia, I measured carbon monoxide mostly, and using ground-based spectrometers, and sun as a source of radiation. After moving over to the West, I started to analyze data from satellites. Satellites also have the same, not the same, but very similar instrumentation as I used before in Russia. And these spectrometers installed at or on satellites give us the global picture, the possibility to measure methane in the Arctic over sea during polar night. You understand that ground-based measurements over in Arctic Ocean during polar night is very, very difficult logistically.
Yeah, now you're going to have to give me, lesson 101 in what a spectrometer will do.
Yes. This kind of measurements is called remote sensing. Remote sensing means that measurements are on a distance. And spectrometer does not measure concentration itself. it measures the radiation. It may be different sources of radiation. From the ground, it is radiation from the sun. From satellites, it may be either radiation from the sun and reflected from the ground, or it may be radiation from the Earth itself. Any warm, relatively warm body emits radiation.
When I hear the word radiation, I think of nuclear radiation, but you're using it to refer to a much broader range of things, right? Heat or light or...
I'm a physicist. For me, it's natural. Maybe for you, it's...
you have to assume that not only I am dumb, but my audience doesn't know much more than I do. So you have to explain as if to a child.
There are different radiations that differs in wavelengths. So if radiation is very, very fast, it is visible light, for example. If it is changes more slowly, it is infrared radiation. And the sun emits radiation, visible radiation, and also infrared, but mostly visible radiation. So what we see, light and radiation the same, absolutely the same. Light is a kind of radiation, but radiation may be visible, infrared, and microwave, and so on.
Now, what about nuclear radiation?
Nuclear radiation is absolutely different.
Okay, that's all I wanted to get clear about. That we're talking about radiation that's non-nuclear.
Electromagnetic radiation. That's exactly a source of our information about methane and other gases or aerosols or any other information about that can be obtained from satellite spectrometers.
Okay, now we've got you were talking about looking at radiation at nighttime from the Arctic where there's nothing visible. Now, what is it you're going to be picking up when you look for methane, or for example?
Terrestrial Earth's surface emits radiation too. Okay. Not only sun, but also the surface of the Earth, and it emits it daytime, nighttime, all the time. It depends on the temperature of the surface. The higher temperature, the higher radiation. Also, this radiation is received by spectrometer, and then it is resolved onto different spectral regions. In some spectral regions is a frequency of radiation or wavelengths of radiation. At some frequencies or wavelengths, methane absorbs this radiation. You see?
Something absorbs radiation? What does?
Methane and other.
Methane absorbs radiation.
Yes, electromagnetic radiation. It's also.
Both.
I simplify it a little bit.
Does everything emit radiation?
Sorry?
Does everything emit radiation? Am I emitting radiation right now?
Yes, and yes. If you if you go to hospital, at the entrance, they have a special device to your into your skin, and it shows the temperature. Yes.
So the temperature is radiation. Okay.
The higher temperature, the higher radiation. And this photometer, it is called photometer. is directed to you, and it received radiation from your body.
Oh, so okay.
The
So it's
higher
like
temperature,
these
the higher,
thermometers that they use at the airport and things, those are small spectrometers.
yes, it may be a spectrometer too. Yes.
Okay.
Or
See how
very
smart
simple-
I'm getting? I'm really getting educated today. Thank you. Because this is stuff I should know, but I didn't know this. Okay.
In 2000, it was the first satellite that measures tropospheric gases was launched. It was called MOPIT. In 2002, the second instrument was launched. After that, during these 2 decades, from 2002, we have lots of data about global concentrations of methane.
So you can show maps of where there's methane being emitted. I would think that pretty soon, as soon as it gets in the air, it's going to be moving around anyway. Doesn't it sort of, get all blown around and integrated? Or does it stay in a place long enough so you can tell that where it's coming from?
Yes, methane is emitted in different areas. I will show you.
Yeah, you have some. I believe you already have some photos you want to show me, or graphs or something.
Yes, sure.
Okay.
You see concentrations of methane that was detected by instrument called S for 0.4 kilometers for summertime. And white areas are areas where spectrometer does not work because of low temperature and ice. And you see red spots. It is for 2004. So it's the beginning of measurements.
Now let me see. That's Russia over there where the red is, right? Is that sea where, like the Laptev Sea and that kind of area?
This is Russia, Siberia.
Yeah.
It is snow-covered completely. Canada, Alaska, Greenland.
Right.
And this is Barents Sea.
Barents Sea? Oh.
Barents Sea, it's Spitsbergen. This is Novaya Zemlya, Russian island, and this is Kara Sea. In winter, but in summer it's okay. In summer, everything is visible.
But now you're saying that this red means that they're around in Scandinavia, they're emitting a lot of methane?
Not Scandinavia. It is the higher concentration of methane. For example, in Barents Sea, Kara Sea, more than over Atlantic Ocean. This is Atlantic Ocean.
Okay.
Then let's compare with the picture that was detected, that was measured in 2019. And you see again in summer. It's actually it's May, July 2019. And winter, early winter, November, December, January 19 and January 2020. And you see difference between them. So that means that methane increased between 2004 and 2019.
Oh, so there's that much difference.
Yes.
Oh my. Ooh.
but
But I'm sorry, but now that's only in the winter, but not in the summer.
but not in the summer.
Why?
To be more specific,
Say it again. Pardon?
to be more specific, there is also a global trend, not Arctic trend. This global trend is 3 ppb. ppb is a measure of concentrations. Every year, concentration globally increases with 3 ppb per year. And the scales are changed, take into account this global trend. So no difference between them means that globally and in the Arctic concentration increased 15 by 345 ppb. Okay, you see. So that means that Arctic ocean increases, methane from the Arctic Ocean increases faster than globally. So this is argument in favor of existence of methane emission from.
Oh, hold on. Let me make sure I know what you're saying. The right hand, the two large graphs on the right hand are global. Is that?
No, that's not global. That's the view from North Pole.
Okay, they're all from the North Pole, but you said that that the North Pole is the northern area is increasing the methane emissions more than the globe, just all over the world. So there's a lot more emissions coming out of the Arctic, and especially in the winter.
Yes, exactly. In the winter, but not more, but faster. That is not a matter of absolute of how high methane emission, but how it is changes in the Arctic seas. It changes faster than here. But compare this area. This is Atlantic Ocean near Great Britain, and compare with this. Changes not much, but changes in Barents Sea and including Laptev Sea too are higher. Not this. In 2004, it was ice-covered area. Ice is changes. Ice diminishing between these 2 years. But this information, briefly, this information is important to make conclusion about how much and how much concentration and how fast it is changes with years.
Well, okay, I'm shocked. Peter, are you shocked?
Well, yeah, I mean, it shows an increasing trend, which is very worrying. Everything involving methane is showing increasing trends.
Yes, it's a concentration, but this, Peter is right, is trends. It's trends in ppb per year. 3 ppb per year is bluish, and here is about 5 ppb per year.
But now explain to me why there's more emission of methane in the winter than the summer.
Oh, it's a good question. You are very smart. Okay. Let's look at this diagram. This diagram explains you the emission, the sources of methane in the Arctic Ocean. This is atmosphere, this satellite that measures methane, and this is sea. These are deposits of natural gas that is 90% consists of methane. Methane flows seeps through the deposits coming to the seabed, and here it partially is converted into methane hydrates. Maybe you heard about that.
Yeah, clathrates, right?
Clathrates, the clathrates.
Mm-hmm.
And after that, methane is going up, lifting, and dissolves in the water. Here in the water, lots of bacteria. These bacteria use methane as food.
Oh yeah, okay. Methanotropic bacteria. Right?
Methanotropic bacteria. Yes, exactly.
Yeah.
They use methane as food, but they need dissolved methane. They cannot eat gaseous methane. They use dissolved methane.
Oh.
So bacteria eaten most of methane, and just a few bubbles going up. This is Barents Sea. Barents Sea, relatively deep, and this is more typical for Laptev Sea. Laptev Sea is shallow, and the shelf, this is shelf, it's permafrost. It is typical for Barents Sea. For Laptev Sea. Laptev Sea and other seas of that area in Siberia, Siberian part. This is Barents Sea that is close to Atlantic Sea, and this is this part of ocean is closer to Pacific, or to Alaska, somewhere in Alaska. Okay, and here is another source of methane, is permafrost.
Right.
Permafrost is thawing, approximately 20%, 20 centimeters per year, changes in permafrost year by year, and also methane clathrates also are found there in Laptev Sea and other seas of that part of Russian coast. Okay, so now, why this seasonal change? It is interesting question. So we have source, we have atmosphere. Between source and atmosphere, water. And in the water, in the Arctic water, we have two kinds of barriers. One kind is pycnocline.
What is that? Pycnocline.
Pycnocline or thermocline. It's the synonyms, almost synonyms. What is pycnocline or thermocline? It is a warm and salty layer. And if you may notice when you swim in a lake, in summertime, you may notice that the upper layer of water is warm and deep water is colder. That's because warm water is lighter than cold water.
Okay.
Atlantic Ocean pushes this warm water into Barents Sea, and this layer is also warmed by sun radiation, electromagnetic by sunlight, and it exists all the summertime. So dissolved methane is locked by pycnocline.
Locked it. So the methane cannot penetrate and escape through the pycnocline.
Yes, exactly. Another barrier is ice. If there is ice cover, that also another barrier. It's easier to.
Yeah, that's what I would have thought. That's why I would expect there'd be more methane emissions in the summer than the winter, because the ice is so covered. You know, how does it penetrate and get through the ice?
In summertime, in northern part of Barents Sea, there is no ice. You're right.
There's no ice on the Barents Sea?
In summertime.
Oh no, but in the winter.
In winter also, Barents Sea, most of Barents Sea is free of ice. Peter knows this better than I.
No kidding.
Yeah.
All right.
Yeah, it's the ice has been retreating all over the Arctic, but the Barents Sea is the part which is closest to Europe, where there's been a especially fast retreat, and so you, as well as you get the ice. Part of it is ice covered in winter, but it's ice free in the summer. And then there's some new results that have just come out that show extreme. Just this last month, there's been extreme warming in the Barents Sea, something like 7 times the normal rate, and that all the ice has disappeared, and we're getting this kind of absolutely unprecedented warming of the Barents Sea, which is another one of these extreme events which is unexplained.
Mm-hmm. Okay.
Now, that means that it's really largely the ice that keeps it down. And when there's a place that there's no ice, then in the winter it's going to come up more.
Yes, it's the ice that sort of holds down the methane, because there's a layer on the seabed, a layer of permafrost, which is sort of frozen ground, and it kind of seals the sediments. It seals everything below it, it's like a pressure cooker, and when that, in the past, that didn't melt in the summer, so you wouldn't have methane coming out of the ocean at any time of year, particularly because it's the ice was there in the winter and the summer. But now the ice is only present in the winter, if at all. Then in the summer, the water warms up, and that thaws the permafrost layer on the seabed and enables the methane to be released. So a big fear amongst methane scientists is that if the climate warms up to the point that you don't get sea ice forming at any time of year in, say, the Barents Sea, then the sediment itself will thaw, which is methane hydrates, and will turn into methane gas. Then the methane will come out in big plumes of gas, and this is something that is already happening. And in fact, at the end, I've got a a couple of slides from another Russian colleague who's been filming that this year in the East Siberian Sea.
Now, according to this map or diagram, the permafrost under the sea is limited pretty much to the shelf. It doesn't. This graph doesn't show much any permafrost at the bottom of the deep Arctic Ocean, right? Now,
Yeah.
is that true, or is it just this particular drawing? Is there also permafrost everywhere, or only mostly on the shelf?
It's mostly on the shelf because if there's any really deep permafrost, well, Leonid could maybe know better than I do, but if it's really deep, then when methane comes out because of the release of pressure, the methane all melts, all dissolves in the ocean on the way to the surface, because methane doesn't dissolve in seawater easily, but it does slowly dissolve. So if the methane is coming out from shallow water, like these pictures we see, then it reaches the surface and is released into the atmosphere and causes all kinds of mayhem. But if it's released in deep water, then it doesn't reach the surface. Like the little picture here on the bottom right corner, it shows methane, some methane bursts coming out of the seabed, but not reaching the surface. The methane is dissolving before it reaches the surface, so that plume of methane disappears. Whereas if the water was shallower, the plume of methane would reach the surface and get into the atmosphere and cause general chaos.
When you say the methane dissolves, what exactly, I guess I don't quite know what that would amount to. What happens when you have a methane bubble that dissolves?
Well, it's just a gas bubble, and because it's soluble in water, the bubble just shrinks and disappears because it's all the gas has dissolved into the water. So it's a slow process. So if you've got a methane plume or bubble plume coming out of the seabed, it can get to the surface without dissolving, and then you have methane gas bubbling out of. It will look a bit like the Nord Stream gas pipeline. Great.
Well, now this shelf, look, in terms of the amount of, where did you say this shallow part is? Is this the Barents Sea? Where's the shallow spot? And you're getting more emissions on the shelf or not than in the deep part of the ocean?
Peter, I'm showing the shallowest part. It's here.
Yeah. Yeah, there's about a third of the Arctic is very shallow, and
very shallow.
It's deep.
30-40 meters, but here the depth is 200 meters.
So that's why you're going to get, you could predict further in the future that you'll always get more methane emissions from areas that are on the shelf than in the deeper region, right?
Well, yes, certainly more methane that gets into the atmosphere, yes.
Yeah. Okay. Now, do you have other things you want to show us, Leonid?
Yes. Final result of this study is here. these are estimate of annual methane emission from the Arctic for the last 5 years, using measurements from 3 satellite-based instruments and in milligram, it's flux. Flux means the amount of methane that enters the atmosphere from 1 square meters in milligram per day. After integration or summing this methane for this special areas, we found that emission from the surface Arctic between this circle, it's 60 degrees circle, and the ocean, it is land, and the amount of methane per year that emitted from ocean is blue, is green for land, blue for sea. So we see that the sea emission is 2/3 amount of methane emitted by sea is 2/3 of land emission. Somehow below land emission. And for sea, we can distinguish between higher emitted area. It's called Barents-Kara Sea, but also includes some part of Norwegian Sea. It is BKS. That is approximately a little bit less than half of methane is of total Arctic Ocean methane is emitted from this area. Other areas also contribute to total emission, but less than Barents-Kara Sea. So this is final results of our study. It was published 1 year ago, and so far this study is not going so fast as before.
Okay, so now trying to sum up the difference between methane emissions over water and methane emissions from permafrost on land.
Yes.
What can we see? Now I see that there's something called WSL, which must be land, and it must be what part of the world is that there?
WSL at the West Siberian lowland. This is an area of swamps. Swamps are another important source of methane, not just Arctic methane, but different kinds of swamps. I'm not quite familiar is mirrors. So I'm not sure about terminology, but ordinary word is swamps.
Okay, now over there at OKH, that must be Western Siberia, right? And you've got a red hot spot over there. What is that again? Go over to the OKH. What is that? And why is it red?
Okay. It's Okhotsk Sea of Okhotsk, Sea of Okhotsk, this area. And this is well-known place for extraction of oil and gas. And
So is that where the methane is coming from, on land?
It's not land, it's the sea. Okhotsk, Sea of Okhotsk.
Are they getting oil and gas out of the ocean there?
Yes, in concentration with different estimates from different satellites, but it is significant source of methane. It is well known, studied for maybe 30 years, and found lots of clathrates in there. And
now I'm very interested.
But it's not Arctic, you see.
In what these Zima folks out in Siberia, Cherkasy or someplace, and they're I've seen so many photos of cliffs of black melting permafrost with all these bones and things in it. Where is that on the map? And it doesn't seem to show on this map as anything dramatic. Is that right? Because that's what I hear about the most, is all of the methane coming out of that area on land.
It's a good question. Difference between marine sources, oceanic sources, and terrestrial sources is in patchy nature of marine sources, but terrestrial sources are spread over entire Arctic terrestrial areas, and that's why in annual emission, the land emits more than sea, but it's some kind of illusion.
Some kind of what?
Illusion. Misunderstanding.
Well, are you saying we shouldn't worry as much about the permafrost as we do the clathrates?
Permafrost. Oh, it's a complicated question. It's not easy. Permafrost is another source of methane, but clathrates are just part of methane from permafrost.
Oh, there are clathrates in the permafrost too. I thought clathrates were just in the ocean.
Yes, clathrates both in the ocean and in the permafrost.
Oh, okay.
Yeah.
All right.
So just maybe it's clear from the conclusions here that you've got total emission of about from the ocean sources. That's the Sea of Okhotsk and the Siberian Sea and Barents Sea, Kara Sea. The ocean sources is 2/3 of the emissions from the land, and that's a very important result, because something that people have been talking about over the last few years is what's the contribution of thawing permafrost on land to the methane emissions, and the reason for worry is that there's a huge area of permafrost in the northern hemisphere in Eurasia, and the quantity of permafrost is vastly greater than the quantity that's going to be available from the ocean. But the question is, how fast will it come out? Because when the permafrost melts, or when it thaws, it turns into this gunky, rotting vegetation. The vegetation then has to rot and produce a variety of gases, one of which is methane. So the question is, you've got a huge area of permafrost on the landmass of Siberia thawing away, but at a rate which we don't fully understand how much methane it's producing, but it's producing methane. And the estimates that I've seen are that in the end, there will be more permafrost, there'll be more methane to come out of the melted permafrost on land than there will be from the ocean. So these sudden possible bursts of methane from the Arctic seas, which could cause gigantic damage if they come out very quickly, will be very, very dangerous. But the slower emissions from land, in the end, will produce a greater amount of permafrost, of methane rather. Mm. So we have to worry in the long run. We need to worry about melting permafrost on land, while in the short run we have to be terrified by sudden outbreaks of methane coming out of the East Siberian Sea and other coastal seas.
Okay, but now look, I would hardly take encouragement from that because because of all these explosions of these circular, what do they call these things, where there's a big blast in Siberia. They found 20 or so of these huge craters where there have been explosions. So if they're happening on land, are they happening under the sea too? And we don't know, maybe we don't know about them, but because you don't see a pit the way you would on land. But is it happening everywhere that there could be big explosions? And why would you worry more about explosions under the sea than on land?
Well, I guess under the sea it's more sudden. I mean, it's something that could produce a huge amount of methane in a short time.
But what about those explosions in Siberia on the land? Those huge craters are like a block or two, in diameter.
Well, I don't know what the absolute quantity of methane is that comes out of one of those. Huh. Maybe Leonid has more information than I do, but I think there's only been about 20 explosions so far, and the quantity, again, if you measure it, compare it with the Nord Stream pipeline, which is the measure of large emissions of methane, then maybe it's not so extreme. That's
an interesting point, because we've been reassured. They always reassure people when, even if it's false, that it's really not such a big emission from that Nord Stream sabotage. But it sounds to me like something they ought to worry about. Why doesn't somebody tell them hurry and set fire to that stuff? Because don't you want to burn it off as quick as possible? So it, but they haven't set fire to it. They should do that, shouldn't they?
Well, yes, I think so. I mean, I've had lots of letters and about that. People saying, why? When you burn methane, you're turning it into carbon dioxide, which is sort of less than 5% of the global warming potential. Then just burn it all off, and it may be some practical problem concerned with causing an explosion or something, but I don't know. It seems to me to be obvious that you should go around burning off.
Why don't you phone them? Say, I am Peter Wadhams and I know what I'm talking about, so you set fire to that thing.
Well, I can try.
Yeah, they'd listen to you. I don't know. Or maybe, of course, the Russians might listen to Leonid. Good. Do people in Russia listen to you any more than they would listen to me or Peter?
I think so.
My feeling is, I don't have the impression that the Russian government is doing much to promote climate research, or certainly any changes in policies that would affect climate in Russia. So you're an expatriate Russian, and I just wonder how much research is going on there, and how seriously are scientists taken when they make recommendations for handling problems, climate issues. How much is the government paying attention to those people, and would they pay any more attention to you as now a Westerner than they would to Peter or me?
Actually, I published a few papers in co-authorship with Russians in Russian journal in Russian language. So to be certain, in 2019, I presented two reports there in my former institute, and also in another institute. So there is a very interesting study of Arctic methane in Russia is going on. So it is going definitely, and especially I was impressed by people from Skolkovo, maybe Peter knows this institute, Skolkovo, and they found methane clathrates in permafrost that may exist at normal pressure. It's a very interesting effect. So this is going, but if you are asking about governmental efforts, I have no idea.
You have no idea. Well, okay, but so I mean, am I wrong in thinking that the government is almost in denial? The way Trump was in denial in the U.S. and just ignoring the problem. Is that true as much in Russia, that the government is just ignoring the problem? Or are they actually supporting research and maybe will make some changes in practices as you discover more? Of course, I don't know how many things we can figure out to do to solve the problem, but if there are changes that need to be made in various practices, do they work on trying to fix the problem or not?
Fix? What do you mean fix? There are several effects of global warming in Russia, and two kinds of response. One response is bureaucratic response in writing papers, in writing reports, special meetings, and so on. And another way of response is response on a local scale. For example, if you go to Siberia, to Arctic coast of Siberia, you would see that some measures are taken for accommodation to warming. Sowing permafrost is a great problem, and it is understood by Russian, and they try to make measures against this to make the life easier in this, and to prevent destructions of buildings and so on. So there's also two kinds of response. Yes.
The only Russians I know mostly just talk about it as if it's not even a problem. And I think there must be lots of scientists who are very aware of the problem and are working on it. But I'm not, I'm not in contact with those people, and I see no evidence here of the kind of research they're doing. Are you strongly in contact with people in Russia, other scientists who are studying either any of the topics that you've been discussing?
Mm-hmm. Yes. Couple of years ago, I published a popular article in a well-known Russian magazine, and I noticed that this article was read by many. So also in public also is aware of Arctic problem. The editor of the journal also was very kind, and he invited me to write another paper. So it's also going on.
Okay, I'm glad to hear it. Because now, for example, it was not just Russian, but the New York Times, 6 months or so ago, published an article. I think it was a big article in maybe the Sunday Times magazine. And they were enthusiastically excited and pleased by the melting permafrost in Russia, because the theory was, this author said, it's going to turn all this land into arable land that they couldn't grow crops on before. And now with the permafrost gone, they'll be able to raise all this wonderful food. And I thought, you are out of your minds. Don't you know what this melting permafrost is going to do? And they didn't once mention it as a problem. So this is a kind of stupid, lack of awareness of the dangers that really upset me. And maybe I don't need to be upset, but I'm upset already with the people around me in North America and Europe who deny it. And I'm even more upset with the people I know in Russia who seem oblivious to the whole thing. So maybe I'm wrong
too. My contacts are not very wide and maybe limited. So I do not insist that this is no problem. Maybe there is no.
I was in touch with Igor Seveletov, who's works on field studies of methane in the East Siberian Sea, and he each year goes out to here. It goes out with usually a Russian ship, and to look at this release of methane from the seabed, and is it getting to be more extreme? And he's finding usually that from year to year, the amount of methane released in plumes from the seabed goes up. So it's getting to be a more serious problem, although not disastrous as yet. Okay. Well, this is looking straight down at the sea surface from the ship, and the green is a mass of methane bubbles that's rising to the surface but hasn't reached the surface yet. So that's this mass here. So it's not, doesn't look very impressive. It will look better when the whole load of gas reaches the surface. Then this is Seveletov and his Swedish colleags. Then this, in contrast, this is just a picture of the sabotaged gas pipeline, and of course it's much bigger. It's a much bigger outbreak, of course, but it's the same thing. It's gas bubbles rising to the surface, being emitted into the atmosphere.
This has been fascinating, and I really appreciate it very much. Bye, Leonette. I don't see you, but I guess you're there.
Yes,
Thank
bye
you.
bye.
See you.
Bye.
I enjoyed this talk very much. Thank you.
Bye-bye. Project Save the World produces 2 of these shows each week, and this is episode 507. You can watch or listen to them as audio podcasts on our website, tosavetheworld.ca. People share information there about 6 global issues. And to find a particular talk show, you can enter its title or episode number in the search bar, or the name of one of the guest speakers. Project Save the World also produces a quarterly online publication, Peace Magazine. You can subscribe for $20 Canadian per year. Just go to pressreader.com on your browser, and in the search bar, enter the word peace. You'll see buttons to click to subscribe.